I want to integrate sine of x times the sine of 3x dx. So I've written down two identities that your teachers or professors might have taught you in the trigonometry classes. So these identities must be known to you, but I'm just now going to derive another identity by subtracting these two equations. So if I subtract these two equations, I will get cosine of a plus b minus cosine of a minus b is equal to, these two will cancel out, right? So you'll be left with negative of this, so that's negative 2 sine of a times the sine of b. And if I multiply by negative 1 on both sides, I get that this is cosine of a minus b minus cosine of a plus b is equal to 2 sine of a times the sine of b. So this is one more identity that you might have known, but I kind of didn't assume that you knew it, so I just proved it now. That's not necessary. Okay, so this is the identity that I'm going to use. So I'm going to rewrite the integral. Let me make a so sorry about this. Okay, so I'll make a separated there. Okay, so this becomes the I'm going to multiply divide by 2, so this is 1/2 times the integral of 2 this pen sine of x times sine of 3x dx. So you see that there is a lot of familiarity between this expression and the one we have here. So this is 1/2 times the integral of, so I'm going to write this as this. So instead of a and b, we have x and 3x. So this becomes the cosine of a minus b. A minus b is negative 2x minus cosine of a plus b. A plus b is 1 plus 4, which is 4x dx. So this is 1/2 times the integral of, now cosine of negative 2x, actually cosine of negative theta is nothing but the cosine of theta. So this becomes the cosine of 2x without a negative sign minus cosine of 4x dx. So this is 1/2 times the integral of cosine of 2x is I believe you know that, so it is the sine of 2x over 2, right? And I'm subtracting from that sine of 4x over 4, right? If you differentiate sine of 2x, you get cosine of 2x times 2, but the 2's cancel out and you get cosine of 2x. So that kind of works out. So this is a plus c here, and there you go, we have just solved the problem. This is our final answer. And in the some 3 or 4 videos I've been doing the videos on miscellaneous integrals, which involve not quite the basic techniques that we have learned so far, like integration by parts, partial fractions, or some of them involve u substitution, but mostly involve some identities that we learned in our lower classes. So yeah, there are some integrals out there which involve these type of procedures. So yeah, and So I'll see you in the next video.